Welcome to AP Biology. Today I want to go over a probability rule with you. It's called the product rule. And so the product rule says that the probability of two independent events occurring together can be calculated by multiplying the individual probabilities of both. So if you're looking for this and this, two things, both things happening, then you would multiply. So you might remember from the last video that if you have a heterozygous dihybrid, maybe maybe seed shape and seed color. If you mate that with itself or with another one that's heterozygous, you're going to get a 9 to 3 to 3 to 1 ratio if the genes are unlinked, which they are in this case. And so what's the probability of producing an offspring that's completely homozygous recessive? That is just the 1 here. It would be 1 out of 16, right? Because there are 16 boxes. So you get 1 out of 16 chances of getting this one. So another way to do that, if you don't feel like doing this huge Punnett Square out, you could also say, okay, the probability that big R little r mated with big R little r would produce this part, just little r. So here's big R little r mated with big R little r. The probability that they would make a baby that's homozygous recessive is 1/4. And then let's do the same thing, but repeat it for the Ys. Oops, don't know what I just did. Okay, let's repeat that for the Ys. So if you have big Y, little y, and you mate it with itself, or one just like it, big Y, little y, the chances of getting little y are also 1/4. And so the probability, the product rule says that you multiply those. So 1 times 1 is 1, 4 times 4 is 16, and oh my gosh, you get the same probability that we had gotten before. Coolio, right? So the probability of this heterozygous one mating with this one and producing both homozygous recessive is 1/4. Do a tiny little Punnett square and you can get that. Big Y little y mating with big Y little y, the probability of getting from the heterozygous parents of getting a homozygous recessive is 1/4. So the probability of both, of getting a baby who's little r and little y, that's the both part, means you multiply. 1/4 times 1/4 is 1/16. And that is indeed the probability we get when we do the whole cross out. Okay, so let's try one more problem. Let's say you have freckles, dimples, and widow's peak, but your mom didn't, which means you're heterozygous for all of them. Let's just assume that freckles and dimples or widow's peak are dominant. I don't know if they are or not, but let's say your mate, so this is you. You're heterozygous for all of these traits. And let's say your mate was like you except had a continuous hairline. So they were heterozygous for the freckles and the dimples, but not for the widow's peak. What are the chances that you would have a cute little baby who's recessive for everything? So you are, let's see, I think you were heterozygous for everything, the Fs, the Ds, and the Ws. And then your mate was heterozygous for the first two traits, but homozygous recessive for the last one. Okay, so the chances that you would make a baby with little f with these two parents would be 1/4. And remember, that's because you can do this Punnett square, right? Do a quick Punnett square if you need to. Big F, little f would be both parents, and the chances that you'd get a baby who's little f is 1/4. And you can repeat that with the Ds. These are heterozygous, so the chances of having a baby who is homozygous recessive from heterozygous parents is also 1/4. Now the hairline, the widow's peak is a little bit different. So you are big W, little w, but your mate is little w. So the chances that you'd have a baby who's recessive is actually 1/4. It's actually 1/2. It's both of these. So that's times 1/2. So it would be 1 times 1 times 1. 4 times 4 is 16, times 2 is 32, I think. So the chances of having a baby who is totally recessive for all of these things is 1 out of 32.